Introduction to arc functions. So for a little bit now, I've been focusing and kind of hammering down on standard trigonometric functions. So I went over sine, which we know sine of theta is equal to opposite over hypotenuse. I went over cosine, which is cosine of theta is equal to the adjacent side over the hypotenuse. And I also went over tangent, which is tan of theta is equal to the opposite side over adjacent side. So I went over some very basic trigonometric functions here, sine, cosine, and tangent, and their ratios. But now it's time to introduce you to something new, arc functions. So typically, we don't see arc functions, or we don't refer to them as arc functions when you start as base level trig. But I'm going to introduce them as arc functions just because some people can get them confused, and there's also different ways to symbolize this. So on calculators, you might have seen something like this. You might have seen sine, but then it says -1, or cosine, negative to the -1 power, tangent to the -1 power. Well, this right here, these are arc functions. So sine to the -1 power, that's the same thing as saying arc sine. So arc sine. Cosine to the -1 power is the same thing as saying arc cosine. And tangent to the -1 power is the same thing as saying arc tangent, as you could imagine. But here's the thing. These aren't regular trigonometric functions like I went over in the past. In the past, like sine, for example, if we use sine, the input of the function, so if we use sine here, we notice that the input of the function is an angle, right? Well, typically when you input the angle, your returning value is typically a side value, so a side length. So your output, you input an angle and you typically get a side length as an output. But here's the thing with the arc functions. The arc functions, so if here, I'm going to keep it simple. So arc sine, we'll say arc sine, for example. The input isn't an angle, it's actually a ratio. So the input is actually two side lengths. So you input, here, let's just use simple notation. You input two side lengths, right? So you input two side lengths, and your output is an angle, right? So a way to think of it is your standard trig functions like sine, cosine, and tangent input an angle and return a sine length, a side length. An arc function inputs two side lengths and returns the angle. So let's use that right now in an example here. So let's say we have our triangle here. All right. So let's say we want to find this angle here, right? So this is theta, right? And let's say this side here is, we're going to say this is 30 centimeters, and this we'll say is like 47 centimeters. Now, what are we going to use in terms of arc sine, arc cosine, or arc tangent? Well, first of all, let's just look at trig functions in general. Are we going to be using sine, cosine, tangent, arc sine, arc cosine, or arc tangent? Well, first of all, we cannot use sine, we cannot use cosine, and we cannot use tangent. We can't use these because we don't know this angle, right? We have an angle, but we don't know the value of the angle, right? We just denote it with theta, right? It's unknown. So we can't use sine, cosine, or tangent because you need to input an angle to the function to get any value out of it, right? And we're not solving for a side length, so we can't use those as well because when you input an angle into these sine, cosine, or tangent functions, you return a side length. And we're not trying to find for the hypotenuse. We're not trying to find for this side or this side. These are already defined. We're trying to find for an angle. So we can rule out that we won't be using sine, cosine, or tangent. So what are we going to be using? What are our options? Well, we have arc sine, right? We can use arc sine. We can use arc cosine. And we could use arc tangent, right? Well, we can use one of these three trig functions here, these arc functions, I like to call them. And yes, these are proper terms. Yes, they are indeed called arc sine, arc cosine, and arc tangent. It's nothing I made up. It's just sometimes on calculators or more simple notation, some people find it better, easier, just they like it to write it this way, but you can indeed write it that way. Let me get a nice little box here. You can indeed write it this way. This is not wrong. And in fact, calculators use this because it's a bit more compact notation and it's easier to print on a display. So yes, the sine to the negative 1, you can also write that as well. It just means the same thing, that you're not right or you're not wrong if you use sine to the negative 1 or arc sine. They're the same thing. Same with arc cosine, cosine to the negative 1, tangent to the negative 1, and arc tangent. Same thing. So out of arc sine, arc cosine, and arc tangent, which one are we going to be using? Well, we can rule out. Well, let's look at arc sine here. So arc sine involves the same properties of sine. So sine uses the hypotenuse and the opposite side. We have the opposite side here, but we don't have the hypotenuse. So we can rule out this, right? Same with arc cosine. Arc cosine uses the hypotenuse, and we aren't finding for the hypotenuse. We don't have anything about the hypotenuse, so we can't use that. So our best bet is to use arc tangent, because tangent involves the adjacent side, which we do have here, 30, and the opposite side here that we also have, 47, right? And we're going to look at that. So now let's use arc tangent to find for this missing angle. So we can say arc tangent, and now we're going to put it in the same order. So tangent is opposite over adjacent. So now we're going to put it as 47 over 30, because that's the same thing as opposite over adjacent. 47 is the opposite, 30 is the adjacent. And this is going to return our angle here. So if we do this, we're going to do second tan negative 1, 47 over 30. And our angle is approximately 57.4 degrees. 57.4 degrees. 57.4 degrees here. So this is the, mathematically, it doesn't look visually here, maybe not, but according to arctangent here, this angle theta right here is 57.4 degrees, or around there. And this is actually the same thing, and if anybody's confused, this is the same thing as writing this, not sine. It's the exact same thing as writing this. Alright, it's the exact same thing as writing this. You're going to get the same result. Tangent to the negative 1 power is the same thing as arctangent. Alright, that is the exact same thing here. Now let's look at using maybe cosine, arc cosine here. So I'm going to erase all of this. I'm going to keep our side notes just so you guys are aware and you can follow through. So now let's get a fresh triangle here. Let's get our pen here. Now let's go from the top here. Now let's say we're trying to find for this angle. And the hypotenuse length is, I don't know, we'll say 16 feet. The units don't necessarily matter, by the way. I'm just using it. And let's say this adjacent side here is, I don't know, we'll say 11 feet. Right? 11 feet. So what are we going to use? Well, we can't use sine, cosine, or tangent because it requires a input that is a angle, and we don't know the angle, so we have to use an arc function. But which of the arc functions are we going to be using? Well, we're dealing with the hypotenuse and the adjacent side, so we must use the arc cosine function because cosine involves the adjacent and the hypotenuse sides. So now, let's say arc cosine. Now, let's put it in the same order. So cosine is equal to adjacent over hypotenuse. So we're going to say adjacent, which is 11, over the hypotenuse, which is 16. And this should return our angle. Note, this is the same thing as writing this. It's the exact same thing, right? It's the exact same thing as that. And let me put this into a calculator. 11 divided by 16. It's about 46.6 degrees. So 46.6 degrees. So we now know theta is equal to 46.6 degrees. And that is using arc functions in trigonometry.